Hello, hello. I hope you're doing well. L119 Complex Fractions. Happy Thursday. Yeah. No. Wednesday. Odin's Day. We test tomorrow on Thursday. Okay. So let's first define a complex fraction, which is basically a fraction containing one or more fractions in the... What do you guys think? Yeah. Numerator. Or the... Good. Denominator. Or the... No. No. Yeah, both. Yeah, good job. Okay. So here's some examples of that. So if, let's say I had a fraction in the numerator. Now, remember, mixed numbers are fractions too. So what if I had 16 and 2/3 over 100? That is considered a complex fraction. Why? Well, because there's a fraction in the numerator. Let's focus what would be an example of one in the denominator. What if I had 15 over 6 and 2/3? This is considered a complex fraction. Why? Well, because there's a fractional form in the denominator. And then, how about this one? 1/5 over 2/3. Again, clearly we see a fraction in both the numerator and the denominator. Now, you probably know what principle we're going to offer on this. It is a Pavlovian phrase, and it simply starts as every fraction. Yeah, you know. Every fraction is a division problem lying in wait. So if we were to take this first one, this 16 and 2/3, I would say, okay, so that's 16 and 2/3 divided by 100. And then we know how to do that. Or if I was to take this this next one, I would say, oh, well, won't that be 15 divided by 6 and 2/3? Yes, it sure would. And then you'd have to remember things like crucial first step. And then how about this one? Well, wouldn't it just be 1/5 divided by 2/3? It would, and then we'd, operate under state change flip, so that'd be 1/5 times 3/2. We'd look for cross-canceling, there is none, and we'd say, oh, it's equal to 3/10, and we box that up. That's kind of what complex fractions are about. Now, these do lead to a larger idea that you'll see next year in your Algebra 1, which we're going to kind of peer into right at the very end. But let's just do the problems that Saxon has offered until I give you the extra special surprise one. So here we have 1/2 plus 1/3. Over 1/3 plus 1/4. Now, clearly, there's fractions all over this thing, so this would be considered a complex fraction. We know we could simplify the first. We'd have to the numerator. We'd have to focus on the fact that this 2 and this 3 are not shared denominators. So I could make the 1/2 into 3/6 and the 1/3 into 2/3, or 2/6, my bad. And then I place that over, so I've got 3 and 4. I know their shared denominator will be 12. So I'll say, okay, 4/12 plus 3/12. And then I can simplify 3/6 plus 2/6, so that will be equal to 5/6 over 7/12. Again, still dealing with a complex fraction. We know that every fraction is a division problem. So I'd say, okay, so this is 5/6 divided by 7/12. Then I'd state change flip it at 5/6 times 12/7. Look for my cross-canceling. Oop, I got them. 1 and 2. And then I'd multiply across and say, hey, that's 10/7. Boom. Now, is that the only way to do it? No. In fact, next year. So what complex fractions are, really technically they're called complex rational expressions, which is, it falls under the hardest unit of the book that we use this year. I don't know what book you guys will be using next year because I borrow those books, so I'm not sure what the plan is for you. But if you guys even do rational expressions and equations, we're going to kind of do it in a different way. And I'm going to show you this same problem and how it would look. But generally what we do with mostly next year is a bunch of variables, and that will be the special surprise problem. But just real quick, what I could do instead of me going off to the right is I could decide, what's the LCM of my denominators, or the LCD? And 2, 3, and 4, I'd have to say it's 12. So what I can do is I can multiply both sides by, and again, I can't change value, so it has to be equal to 1. But what I'll multiply it by is 12 over 12. And then I'd wrap. And then as I move across, and so I think about the 12, and I think about multiplying it by this 1/2. Now, 12 times 1/2 is clearly 6. Okay, how about this 12 times the 3? Well, not times 3, times 1/3. That would be 4, right? And then I'll do my denominator portion. So 12 times 1/3, well, we already know that's 4. And then 12 times 1/4, we know is 3. And then I'd get, 10/7. I get the same thing. You might go, well, why don't I just do it that way? You can. You totally can. I mean, it's not we are really looking ahead, and we're using a method that you will hopefully be taught at some point in your life. But to tell you the truth, not a lot of 8th grade algebra goes through rational expressions, so you might be stuck with the one on the right. But hey, that's just a look ahead. Let's do one more there. I think one more. Yeah, one more of their problems, and then I'll show you the special surprise problem. Now, we've dealt with this before, maybe not with something as complex as 28 and 4/7%. However, we do know that percent means of 100. So what I can do is I can form a complex fraction out of this by saying, okay, 28 and 4/7 of 100, or divided by 100. We know every fraction is a division problem, so I'd say, okay, 28 and 4/7 divided by 100. Crucial first step, I don't know what this is going to be. So 28 times 7, 56, carry the 5, 2 times 7, 14, 19, plus the 4, don't forget the 4. So that's going to be 207 divided by 100. Now the state change flippy, 207 multiplied by 100th. Nice cross canceling, 1, 2, and bet you didn't know it, but 28 and 4/7% is precisely equal to 2/7. You can plug it in your calculator and prove it for yourself. But yeah, it's true. It's how it works. Okay, so now this is all just a purely look ahead. You are free to write this down. I am going to walk you through this. This is something we'd see in what was Unit 10 of the book we used this year. And as I said, that Unit 10 is always the one that makes A students into B students. So if you do engage in what are called rational expressions or equations, hold on tight, people. It's tough. You can ask any of the current 8th graders that are in 8 Blue about it. But yeah, okay. So we're going to focus on that LCM thing like before. So if I see in my denominators I've got an x and x squared, well, that would be the common multiple, right, would be the x squared. And then the 3 isn't going to be important. So essentially the LCM, the least common multiple, is 3x squared. And like I showed you before with just the regular numbers, what we'd end up doing, and again, you are not responsible for knowing this, we're just peering into your future, is I would multiply by a fractional form equal to 1. So I'd say 3x squared over 3x squared. Now it's important to remember that when this 3x squared comes across, it's in the numerator position. And that just means in the numerator of the numerator. It is multiplying against 1 over x. So what would happen when I multiply it by the x is that one of those x's would cancel out, and I'd be left with 3x. Now over here, when I focus on the 3x squared and I multiply by the x squared, what we'd see is that those x squareds would cancel out, and I'd be left with just positive 3. Now I'm still in a fractional form. So then I'd take this 3x squared and I'd multiply it by 1 over 3x. I'd see that the 3 and the x would cancel, and I'd left with just be x. Now you have been exposed a little bit to factoring in the sense of GCF. And so in looking at the numerator, I'd see that the GCF is 3. So I'd put the 3, I'd open up a set of parentheses, and I'd divide out 3x divided by 3 is x. And then positive 3 divided by 3 is positive 1. And I'd place that over x. Now, what you'll find if you ever do engage in this stuff, or when you do, is that there will be potentially more canceling. Like really complex things like what you saw, they could all end up becoming 1 or 2 or something like that. But again, don't worry. Like this whole last page, I didn't care if you wrote it. I just wanted to peer into the future. And I do want to say that I wish in so many ways that I would have been the one to teach you this. But that's not how things shook out. I know that you are very strong, and not just in math. And you have worked very hard for me. We're not done, but in the fact that I just kind of showed a super algebra thing, it is what it is. And though I at one point thought I would be teaching you algebra, it's going to be someone else. And I encourage you to give to them what they need and give to the subject what it needs. You've worked so hard for me over the past 3 years that I'm just in awe. I am in awe over what you've done. I'm not amazed. I don't think it's amazing because I'm not confounded by it. I'm just in awe. It has been an awesome journey. And though it's not quite over, I just want to thank you. And I want to thank you for your hard work. Other than that, I am going to assign homework, HW119, and oh, my friends, we are so knocking on the door of being done. and you should be impressed with yourself. I am super impressed with you. Take good care. Bye.